Welcome back, everyone. Let's start O-level chemistry, paper 4, alternative to practical paper, May, June 2025, variance 42. We have done 41 in the last class. Let's talk about 42 now. A student investigate how the solubility of solid potassium nitrate varies with temperature. I've told you in the last variant, that is in variant 41, that solubility is basically the mass of solute in gram solute is basically the solid substance which is going to be soluble in water या जिसकी हमें solubility determine करनी है उसको solute कहते हैं. The mass of solute in gram it dissolved in 1 dm cube of water, and water is basically the solvent. Solvent is a substance जिसमें हम किसी भी compound को dissolve करते हैं. Okay, and also I've told you in variant 1 that solubility depends on temperature. So temperature increases, solubility increases, which means the reaction is going to be endothermic. Okay. By the way, solid potassium nitrate is soluble in water because all nitrates are soluble according to solubility chart, which we have done in the class. Now, solubility always determined in 1 dm cube of water. Since examiner has used 100 cm cube of water, obviously we need to convert this 100 cm cube into dm cube, and it's going to be 0.1 dm cube. Okay. And in variant 1, I have given you the instruction how to go about this sort of calculation, because 1 dm cube equals 2000 cm cube. So when we have 100 cm cube, it's going to be 0.1 dm cube. Okay, that's an easy piece of calculation. So what the examiner is doing is 100 cm cube of water is put into the beaker at room temperature. Okay, measure the mass of the beaker of water, add some potassium nitrate to the water, stir the mixture until all the potassium nitrate dissolves. Okay, since solubility is a temperature dependent, so आप note करो, in these steps, examiner has not shown any sign of temperature, right? He hasn't shown any temperature reading, which means we need to determine the temperature when we add potassium nitrate into the beaker. Okay. Repeat step 3 and 4 until a small amount of undissolved solid remain in the beaker. This might be the source of error, because if the mass of solid remains, it will combine with the total mass. And if the total mass increases, obviously solubility also increases, okay? Which we have done in the last variant also. Then measure the mass of the beaker of water and potassium nitrate. Repeat step 1 and 6 using water at different temperature. Calculate the mass of potassium nitrate dissolved in water at each temperature. Well, in variance 41, examiner has not given us any graph related to solubility, right? मुझे लगता है कि solubility का graph आ सकता है आपके पास, okay? On the basis of that, I conclude a couple of things here. First, since we are changing temperature, that means it has to be the independent variable. Independent variable always exists on the x-axis. इसका मतलब whenever examiner talks about the graph of solubility versus temperature, so temperature has to be on the x-axis because it is an independent variable. Why it is an independent variable? because what we change is the independent variable and we are changing temperature. And what we measure is dependent variable, and what we measure, we are measuring the solubility in water. So this solubility is going to be a dependent variable, and it has to be on the y-axis. So हो सकता है वो हमसे ग्राफ प्लॉट करवा ले सेम कॉन्सेप्ट के लिए. सो मैं इसके लिए भी रेडी होना चाहिए. Okay, next. The student did not make an important measurement. State the measurement that the student needs to make since it is a temperature dependent. An examiner has not shown any sort of temperature reading, which means temperature has to be there. Okay. Needs to show the temperature at which solubility determines. Okay. Next is the student results are shown in table 1.1. At 15, we have 26.4. That is at room temperature 31.7. At 35, this is going to be the value. Now, at 55 degrees Celsius, there is no solubility given, which we need to measure, obviously. So examiner is looking to estimate the mass of potassium nitrate dissolved in 100 cm cube of water. So obviously, this value has to be lower than this one and greater than these two values, these three values. So how can we decide this value? Well, when we add these two values, I'll get the starting range of the solubility. Let me check. अगर मैं इन दोनों वैल्यूज को ऐड करूंगा तो मुझे सॉलिबिलिटी की वो वैल्यू मालूम हो जाएगी जो कि इससे ज्यादा होगी. ओके, लेट मी चेक. 54.9 प्लस 31.7, my bad, 54.9 plus 31.7, it's going to be 86.6. Okay, so this is a, it has to be greater than this value, it has to be like this. ठीक है, इससे ज्यादा होनी चाहिए वैल्यू, ये रही इससे ज्यादा, और जाहिर सी बात है इससे कम होनी चाहिए. कैसे पता चलेगा इससे कम है? तो मैं ये तीनों वैल्यूज को ऐड कर देता हूं. सो आई गेट द रेंज 54.9 plus 31.7 plus 26.4, so it's going to be 113. So ये रेंज आ गई मेरे पास. ओके, सो मैं इसको रफली 113 नहीं 100 रफली कर देता हूं 120. ओके, बट मैंने आपको आइडिया थ्रो कर दिया कि ये रेंज आप कैसे डिटरमिन करोगे. इन दोनों वैल्यूज को ऐड करूंगा तो ऑब्वियसली 55 डिग्री सेल्सियस के ऊपर सॉलिबिलिटी इन दोनों की वैल्यू से ज्यादा होगी, वो तकरीबन इतनी होगी. और 75 से कम होगी, तो 75 से कितनी कम होगी? इन तीनों वैल्यूज को ऐड करूंगा तो मुझे पता चल जाएगा कि सॉलिबिलिटी मैक्सिमम कितनी हो सकती है. तो ऑन द बेसिस ऑफ दैट मैंने यहाँ पर एक रेंज दे दिया आपको, बट ये आप फिक्स भी लिख सकते हैं 86.6 to 120. ओके, सो मास is going to be 86.6 to 120. ठीक है. The student observes that when the solution made to 75 degrees Celsius is left at room temperature, when 75 degrees Celsius reaches to room temperature, obviously lowering the temperature lowers the solubility value, and as a result of that a solid appear in the beaker. So examiner is looking for explanation, right? When solution is left at room temperature the solution cools down, due to which temperature decreases and solubility decreases. Hence, solid appear in the beaker. Okay. Suggest why the student does not do the experiment at 115 degrees Celsius. See, examiner ने हमें 95 डिग्री सेल्सियस तो दिया लेकिन 150 डिग्री सेल्सियस पे नहीं दिया बिकॉज हम यहाँ पर वाटर को एज अ सॉल्वेंट यूज कर रहे हैं एंड वाटर बॉइल्स एट 100 डिग्री सेल्सियस. Okay. So if water boils at 100 degrees Celsius, we cannot determine the solubility at 115 degrees Celsius because at 100 degrees Celsius, water will turn into steam. And अगर water steam में convert हो गया तो फिर solid dissolve नहीं हो सकेगा. Okay. Because at 100 degrees Celsius, water will turn to steam. Okay. And that's called boiling. When water turns into steam, that's called boiling. Okay. Next is explain why the method the student uses give a higher value of solubility than the true value. I have told you in variance 21 about this. See, solubility has a formula. Mass of solute in gram over volume of solvent. And that solvent is basically water. And it has to be in dm2. Okay. So if mass of solute increases, obviously solubility also increases. Technically, if volume of water decreases due to evaporation or more evaporation, solubility also increases. Okay. So these are the two different aspects of this explanation. So it's totally up to you, whatever you need to write it. So if a small amount of undissolved solid remain in the beaker, it will combine with the total volume. And if it will combine with the total volume, obviously the total mass of the solute increases and this increases the solubility. Let me write it down. Mass of undissolved solid combines with the total volume, total mass. So this increase in mass increases the solubility. Alternate explanation can be written like this: if volume of water evaporates बल्कि इस तरह से लिखें, if more volume of water evaporates, then volume of solvent decreases. If volume of solvent decreases, solubility increases. It could be an alternate explanation for this. Okay. So, दोनों में से जो चाहें लिख सकते हैं, दोनों acceptable होंगी एग्जामिनर के लिए. That's question number 1. Let's talk about question number 2. Solid W is an impure organic acid H3A. Well, in acid basis salt, I've told you that examiner generally represented by all examiner, basically it's an impure organic acid. So first of all, its formula is H3A. That indicates it's a tribasic acid, which means it donates 3 hydrogen ion in aqueous medium. And all tribasic acids either represented by H3X or H3A. That's what we have done in theory classes, right? An examiner is using surprisingly H3A. A student determines the mass of H3A in a sample of W by titration with 0.1 mole per dm cube NaOH. So when tribasic acid like H3A is treated with NaOH, then salt and water is formed. Obviously, the salt is going to be Na3A plus water. Okay. So the molar ratio between NaOH and organic acid is going to be 3:1. That's what we need to remember. The student place the sample of W in the beaker. Okay. So W is basically what? H3A. That is organic acid. Using measuring cylinder to add 100 cm cube of distilled water to the beaker. By the way, measuring cylinder is not the accurate apparatus. As it has in bigger internal diameter. Okay. Stir the mixture until the solid is fully dissolved. And that's the purpose of the stirring the mixture. But in order to stir, either we use magnet or glass rod. Or magnetic stirrer. Then label the mixture X, okay. Prepare 25 cm cube of NaOH into the conical flask and add 5 drops of thymol thallium indicator. By the way, thymol thallium indicator in acid, it shows colorless. In alkali, it gives you blue color. So you should remember what sort of color we have seen in acid and we have seen in alkali. Repeat the titration 2 more times. Explain why it is important to use dilute distilled water, not the tap water for the experiment. Okay, distilled water, not the tap water. Tap water contain So tap water contain impurities like minerals, okay? So it can interfere in the titration process if we use it, which is why we need to avoid tap water, and therefore we need to use distilled water. In fact, distilled water has no impurity. You can write that distilled water has no impurity or dissolved minerals. Figure 2.1 shows the initial and final Buret reading for titration 1. This is 4.2 and this is 23.8. Okay, let me write it down. 4.2 and 23.8. Get the difference of these values is going to be 19.6, then 19.1, and then 19.3. And the best titration is obviously 9.1 and 19.3. And so you will get the average volume of 19.2 cm3. So that's the average volume. And how can we calculate it? पहले भी बता चुके हैं आपको कि you need to add these two values and divide by 2. So exactly you will get 19.2 cm3. Calculate the number of moles of NaOH in 25 cm3 of this concentration. 1000 cm3 of NaOH contain 0.1 mole. When we have 25 cm3 of NaOH, so the moles is going to be 0.0025. Okay. The equation for the reaction between H3A and NaOH is given. And see, the molar ratio between acid and NaOH is 1:3. So examiner is looking for the number of moles of acid that reacts with this amount of NaOH. That's an easy thing. This is H3A and NaOH. This is 1 mole. This is 3 mole. When we have 0.0025, the moles of acid is going to be divided by 3. So it's going to be 8.33 into 10 to the power minus 4. मैंने क्योंकि वैल्यू इस पैटर्न पे लिखी है तो नेक्स्ट आंसर भी इसी पैटर्न पे होना चाहिए, तो ये हो जाएगा 0.000833 मोल्स. ओके, अगर आप वैल्यू इस तरह से लिख रहे हैं 2.5 इंटू 10 टू द पावर माइनस 3, तो फिर आप ये इस तरह से लिख सकते हैं 8.33 इंटू 10 टू द पावर माइनस 4. लेकिन अगर आप इस तरह से वैल्यू दे रहे हैं तो फिर आंसर इसी तरह से जाएगा. ठीक है, तो किसी एक फॉर्मेट को आपने एडजस्ट करके रखना होता है, दोनों नहीं यूज कर सकते. Calculate the number of moles of H3A in the sample of W. In the sample of W, see, the average volume of X is 19.2, and we have got the moles of acid from here. So this moles, calculate the number of moles of H3 in the sample of W. Let me check. Okay. So this average volume contains this much moles of acid. And how much volume we have? 100 cm3. Okay, let's check. 19.2 cm cube of H3A contain 0.000833 moles. So how much volume we have in W? 100 cm cube, if you remember. So if 100 cm cube volume is used, so how much more we have? 19.2. 4.34 into 10 to the power minus 3. तो ये हो जाएगा 0.00434 moles. Okay. So we have used 100 cm cube of distilled water in W. Okay. Okay. Next page. The relative molecular mass of acid is 210. Determine the mass of H3A in the sample of W. Mass of H3A. We have moles, which is 0.00434. And MR is 210. So into 210 is going to be 0.9114. 0.9114 gram. So it's basically 0.91 gram. Okay. All right. In step 2, measuring cylinder is used to add 100 cm cube of distilled water to the beaker. Explain why using the measuring cylinder makes the volume of distilled water used inaccurate. Suggest an improvement. I've told you that the internal diameter of measuring cylinder is bigger than burette and pipette, which is why measuring the volume from distilled water is not going to be very, very accurate. So internal diameter ज्यादा होना केमिस्ट्री में कहते हैं does not have high resolution or can read only 0.5 cm cube. So measuring cylinder has bigger internal diameter. That means does not have high resolution. Improvement. Use burette to measure 100 cm cube of distilled water twice. Because the size of burette is 50 cm cube. So to measure 100 cm cube, we need to use 2 times. We need to measure 50 cm cube volume 2 times. Okay. Before the student does step 6, the burette is rinsed with distilled water and then with X. Okay, तो एग्जामिनर हमसे ये कह रहे हैं कि स्टेप 6 में हमने ब्यूरेट को फिल द ब्यूरेट विद एक्स, तो वो कह रहे हैं कि हमने पहले ब्यूरेट को रिंस किया डिस्टिल वाटर से और फिर एक्स को फिल किया और फिर एक्स से भी किया. एक्सप्लेन व्हाई द ब्यूरेट इज रिंस्ड विद डिस्टिल वाटर, ताकि ब्यूरेट में अगर कोई इंप्योरिटी है तो वो रिमूव हो जाए. टू रिमूव any contamination or impurity from the burette. ठीक है. Okay. Next part of the question. My goodness. Suggest and explain the effect of the titration results if the burette is not rinsed with X after rinsing with distilled water. देखो, after rinsing with distilled water, the solution X becomes diluted or it lowers the concentration. Okay. See, the formula of concentration is this: concentration equals to moles over per unit volume. Okay. If the burette is rinsed only with distilled water, then it makes the solution dilute. And if the solution is dilute, obviously it lowers the concentration. And according to the formula, if concentration decreases, obviously volume of X required for the titration should be increases. So effect is a volume of uh, hold on, 1 minute. Okay. So volume of X required for titration would increase. Will increase. Why? Rinsing with distilled water makes the solution diluted. It lowers the concentration, obviously. Mhm. And more volume of X needed for titration. Okay. Let's move on to the third question. A student investigates solid A and aqueous solution B. Solid A is a metal carbonate. Okay, that's what we need to remember. Solid A is basically metal carbonate. And solid B contain only one cation and one anion. The student does a flame test on solid A. Describe how to do flame test on a solid. First of all, make a solution of solid. Place dry, clean glass rod in a solution of A. Place the glass rod in a blue Bunsen flame. Okay. And then obviously you will get a flame test of solid. The student observes blue-green color in the flame. Identify the cation present. By the way, this blue-green flame color shows the presence of copper ions. Copper 2 ions. Okay. And since examiner is looking for the identification of cation, so we can write the formula also. The student add dilute hydrochloric acid to A. By A is metal carbonate, which means it has to be copper carbonate. Okay, because that metal carbonate contain copper ion. So copper carbonate is reacting with hydrochloric acid, converting into copper chloride, which shows a blue color, water and carbon dioxide. Okay, and this is the gas given off during the process. An aqueous solution C, and that solution C, copper 2 chloride. That's your solution C, and a colorless gas is given off, that is going to be your colorless gas. Okay, and that solution C has a light blue color. You need to remember this also. Describe the observation the student makes, describe the chemical test and positive result used to identify the gas form. Observation: brisk effervescence is given off. This term brisk effervescence is normally used for carbon dioxide gas. Okay. Test: pass the gas through lime water or bubble the gas through lime water. Result: lime water turns milky. Or cloudy. Okay. Explain how the student know when the reaction has finished, when no more effervescence is observed. When no more bubbles of gas is given off your effervescence. Since copper carbonate is a solid at RTP, so when we treat it with hydrochloric acid, then this dissolves. So we can write another observation that solid solid A. Hmm. Hmm. Solid A dissolves solid A dissolves fully. Okay. Next is explain how the student uses aqueous ammonia to confirm metal ion present in C. So examiner wants to test copper ions through ammonia. Include the observations you expect. Add few drops of aqueous ammonia. Blue precipitates are observed, or blue precipitates are formed. Excess ammonia is added. Blue precipitates dissolve. So blue precipitates are soluble and give a dark blue solution. And that's what we have done in the class. So you guys need to remember all these tests and observations. The student does test on B. The results are shown in the table. Identify the anion B. When we add dilute nitric acid and aqueous barium nitrate, colorless solution form. That indicates sulfate ion absent. Okay. When we add silver nitrate, creamy precipitates form. That indicates bromide ion present, because bromide ions gives creamy precipitate. Chloride gives white and iodide gives yellow. Okay. When we add sodium hydroxide, aluminum foil, warm the mixture, colorless solution, that indicates nitrate ion absent. That indicates nitrate ion absent. So identify the anion in B, obviously bromide ions. Okay. My goodness. So we have one cation and one anion. So one cation was copper 2 ions and one anion is bromide ions. So the formula of copper and bromide, uh, oh, that's the only case. Solution B has only one cation and one anion. So one cation, it has no any anion. Okay, fine. That's the answer. Let's move on to the next part of the question. That's planning and analysis, and it's my favorite. Q is a mixture of solid copper to carbonate and solid lead to sulfate. Okay. And I've told you in the class that solid copper to carbonate is insoluble in water. By the way, lead to sulfate is insoluble in water and also insoluble in dilute sulfuric acid. Whereas copper to carbonate is insoluble in water but soluble in dilute sulfuric acid to form copper to sulfate solution. Okay. It's insoluble in water, but obviously copper to carbonate, when treated with sulfuric acid, you will get copper sulfate, which has a blue solution, water, and carbon dioxide gas is given on. Plan an investigation to obtain pure copper to sulfate crystals and pure lead to sulfate solid from Q, which means one thing is soluble and the other one is insoluble. So I'll go for the filtration technique to separate both these. Your plan should describe the use of common laboratory apparatus, dilute sulfuric acid and Q. No other chemical should be used. Your plan includes apparatus needed. You may draw a diagram to help the answer the question. Okay, I don't need to make a diagram because it's very straightforward. But first of all, mixture of solid copper to carbonate and lead to sulfate is placed in a 100 cm3 beaker. वैसे एक बात बता दूं, मैंने ये आपको वेरिएंस 41 में बहुत स्टेप टू स्टेप हेडिंग लगा के करके दिखाया था. सही है. एक फॉर्मेट आपके पास हेडिंग का हो गया, लेकिन अब मैं इसको विदाउट हेडिंग करके दिखा रहा हूँ, सो दैट यू कैन हैव एन आइडिया कि किस तरह से इनको लिखा जाता है, बिकॉज ये कॉन्सेप्ट सेम है, सिर्फ कंपाउंड्स चेंज हो गए। सो लेट्स राइट एट mixture Q in 100 cm cube of beaker. Okay. Add sulfuric acid into this beaker until lead 2 sulfate will remain. Use filter funnel and filter paper. So use filtration method to separate both copper 2 sulfate and lead 2 sulfate by using filter funnel and filter paper. Lead sulfate is collected on the filter paper as residue and filtrate and copper sulfate solution is collected in the flask, in the conical flask, or beaker. My bad. In the conical flask as filtrate. Transfer the filtrate in an evaporating dish or evaporating basin. Heat the filtrate by removing water to make a saturated solution. Cool the saturated solution at RTP. To get the crystals. Okay. To get the crystals. Now the next is wash the residue with distilled water to remove any traces of copper 2 sulfate. Dry the residue on the filter paper. Filter paper. Okay, so I'm done with this. I have shown the apparatus as per requirement. I have prepared and collected copper 2 sulfate copper 2 sulfate solution. I have prepared that. Copper 2 sulfate crystals, I've got that. Pure lead 2 sulfate solid, and we need to test the purity about lead 2 sulfate. What? Let me finish that. Uh, by using melting point apparatus, determine the melting point of lead 2 sulfate. And then compare it with the original value. Okay. Uh, Everything seems fine. I have used beaker. Uh, I've used filter funnel and filter paper. I've used conical flask, collect the filtrate, evaporating dish to transfer. Make a saturate. This is correct. Residue, ठीक है. This one thing, कैसे पता चलेगा मुझे कि रिएक्शन कंप्लीट हो गया? तो मैंने यहाँ लिखा है add sulfuric acid into this beaker until lead to sulfate remains. I think until lead to sulfate remains is fine. गलत तो नहीं है, बट बेहतर ये हो सकता है until effervescence stops coming. Okay. When the effervescence stops coming and when no more effervescence has seen until that's the best statement. Until no more instead of effervescence I can write bubbles because I'm having issues with the space. Bubbles until no more bubbles has seen. Okay, rest is fine. I think you have an idea how to go about in the paragraph form in a systematic order, and how to write if we use headings, right? So you have both the plans, you have both the formats now. That's the end of this paper, guys. I hope it makes sense to you. Thank you very much.